So here's the question, and they're asking us to find the final moment of inertia. Alright, so there are a couple of important concepts for this question. The angular momentum will be conserved. The moment of inertia for a skater is assumed to be that of a solid cylinder. So I equals mr squared divided by 2. And the angular velocity can be rewritten as 2 pi frequency. So angular momentum is I times the angular acceleration, and we just found the formula for that. So we can plug it in as m equals r squared divided by 2 times 2 pi f. Because angular momentum is conserved, the first angular momentum will be equal to the second angular momentum, so you can plug it in and this is what you get. Now when you cancel like terms, there's a lot you can cancel. The m, 2 pi, right? You're left with r1 squared equals r1 squared times frequency 1 equals r2 squared frequency 2. They told us at the beginning of the problem that frequency 1 is 1 over 1.6 revolutions per second, and frequency 2 is 3 revolutions per second. So you plug that in, and here is the formula. So you isolate r2 squared because that's what we're interested in, the second half of the performance when she's increasing her frequency and therefore decreasing her radius. So r2 squared equals r1 squared divided by 1.6 times 3, so that becomes r1 squared divided by 4.8. Now because the r squared is directly proportional to the I, if r2 squared is 1 divided by 4.8 of r1 squared, I2 will be 1 divided by 4.8 of I1. So I2 equals I1 divided by 4.8. From the problem, they told us that I1 was 5.9 kilograms times meters squared. So we divide that by 4.8, and you get 1.229 kilograms per meter squared. And that is your answer.